1993, President Clinton announced a policy to help independent gas and oil producers. One component of the policy involved using computer technology. Following the President's edict, the Department of Energy funded an ongoing program at Los Alamos National Laboratory, a laboratory operated by the University of California for the Department of Energy. Los Alamos joined with independent gas and oil companies to bring advanced computing technologies to help solve the problems of shrinking oil production. One of the projects in this initiative was Carpinteria.
The Carpinteria project itself started back in 1993, and what we're looking at is we have a mature oil field that is basically starting to run out. And the question of the project and why we started the project was to see what is remaining, how much oil has been left behind by the federal lessee, which in this particular instant was Phillips Petroleum. And then there was also the state lessee, Chevron Oil.
The state leases producing from Carpinteria field produced 37 million barrels of oil and 41 billion cubic feet of gas from approximately 83 wells. The field has generated over $60 million for the state of California. And in 1993, Chevron stopped producing the state platforms, Hope and Heidi, and began to abandon these facilities. This made the state leases unreachable except by drilling from the federal platforms, and our revenue went to zero.
At this point, Pacific Operators Offshore Incorporated, who had previously acquired Phillips' interest in the federal portion of the field, acquired Chevron's interest in the state portion of the field. This helped resolve the State Land Commission's problem.
Our company is a small business, and as you know, small businesses employ most of the people in this country are employed by small businesses, and large companies have most of the capital. They employ most of the capital, we employ most of the people, and so you don't have the access to capital or the resources that a major corporation would have.
There was an initiative back in 1993 called the Advanced Computational Technology Initiative, and we attended a conference back in Los Alamos. And as a result of that meeting, actually prior to that meeting, we had got together with the Minerals Management Service and State Lands Commission, and we all agreed that this might be something of interest as a group. And so at that conference, a representative from both the state and the Minerals Management Service attended with me, and we went back to Los Alamos and started forming a relationship with the lab, and eventually we applied for a grant under the Advanced Computational Technology Initiative.
Formed a project team. Each institution took on a special role. The role identified for Los Alamos was to find a way to successfully institute a virtual enterprise out of our activities. And this now was 1993, before the web was a commonplace term in our vocabulary. We didn't know whether the web would in fact support this, but we knew that we could build a wide area network that would connect all the players and allow us to at least experiment with the idea that a virtual enterprise could be used to solve this problem. For the first several years, the team focused on A, establishing the enterprise and the support needed to promote it, and B, consolidate all the data, populate databases with the data so that we could then begin the process of trying to interpret it and analyze it.
I mean, an interesting point is that when we started this collaboration, we had as a baseline, you might say, we had all of the interpretations of all the companies that have been involved in all of those leases. And a lot of them were major oil companies. They all were major oil companies, actually. And what's interesting is that none of them had the same interpretation. I mean, I'm talking about the same property and the same lease. Each company had its own interpretation of what they thought was the geologic setting at Carpinteria. And now we've been able to take and get one picture of Carpinteria.
So far, the results have been in really building a new 3D geologic model of the field. There really was never any geologic interpretation or study done that looked at the whole field as a whole and tried to come up with one interpretation that made sense. And so really what our objective here is to really take all of this old data and put it into digital form, and using really today's technology, employ some really sophisticated 3D modeling software and build this 3D model. And the beauty of having a 3D model is you can rotate it and spin it and cut it, and really it's very visual.
Well, this is a cutaway view again of the Carpinteria field model, and it shows the well bores from the existing platforms, just to give you an idea of how many of the wells are, how many wells there are in this field. This platform here next to the cursor is platform Houchin, I'm sorry. This is platform Hogan, and Hope and Heidi. These two platforms have been removed, but the well bores, of course, still remain. And it's from these well bores that we get the data from which we built the model. Here's a picture that shows the existing holes off the Hogan platform. These are these curved lines here. And also shown on this, these horizontal lines are the redrills that we're planning to do from these existing well bores. This is the principal means by which we plan to redevelop this field. And we've used the model to very accurately locate where these horizontal redrill tracks will go. This view here shows you how the diagram can help us plan these wells. We're seeing a horizontal well right here where the cursor is that's within the F zone, which is that orange-colored band there. So you see that there are 3 horizontal wells that are planned for that zone.
The idea for horizontal drilling now is to not go after all the zones in one well, but to choose which zone in any particular area of the field is the best candidate to go after for permeability, for zone thickness, and porosity. We use the model to decide where that area might be in any particular well, and we target one zone. I don't think you could even start a project like this without modeling, because you're essentially almost wildcatting.
What we're trying to do here, what I'm trying to do, is to go ahead and take today's technology and work on these 30-year-old wells, try and find out where the oil is still left in place, and then be able to try and produce it.
The workover program was all based on a static geological model, which we spent many years building. And we used it to identify various stratigraphic zones that we wanted to target in the workover program. But if we're going to examine where fluids now exist in the reservoir, where oil actually exists in the reservoir now, we need to know how the fluids have moved around in the reservoir. And in order to know that, we need a dynamic simulation model to help guide us. And we've just begun the process of building that dynamic simulation model. That model will really help us evaluate various development scenarios for the reservoir, various new drills, redrills of existing wells, and things like that. I think this dynamic simulation model will help us in the future to really improve the economics of the reservoir as we target those bypassed oil zones.
Really what I think in wrapping up the project and how I feel about this project is that it's been very successful in terms of the cooperation between ourselves and all the partners. The state has been a large contributor in terms of their expertise, in terms of their manpower, in terms of their knowledge that they had, being able to freely access information. These people have been very generous in their time. The people at the lab, I mean, to be able to work with scientists, men and women who are renowned in their field, who are like lightning rods of knowledge.
We feel like this joint study with MMS and State Lands Commission and Los Alamos and Pacific Offshore Operator developed a framework that we can also use it in other part of the state when we have the fields that they straddle between state and federal leases. And by using the same framework, we can do similar type of studies and identify more potential for further development for other operators and increase the revenue for the state and federal.
And really what we've got is a public access database in this particular Carpinteria project that has allowed different institutes to start creating different modeling packages and to be able to take this model, test their hypothesis, test the way that their software is going to predict the future, and see whether or not it's accurate. And the question was, are we finding more oil? Yes. Have we been successful with the 3D modeling? Yes. Are we going to use it for future drilling? I would say yes.
The Carpinteria Partnership joining Pacific Operators Offshore, Los Alamos National Laboratory, the Minerals Management Service of the Department of Interior, and the State Lands Commission of the State of California is one of the best examples of how advanced computer technology can link partners in a virtual enterprise. A virtual enterprise affords access to sophisticated computational tools for reservoir management, which helps increase domestic oil production, increase jobs, and increase state and federal revenues.